Imagine solutions. What a concept. I'm going to spend a little bit of time talking about the ocean. There are some real problems, and we really do need some solutions. And it starts with really understanding. All this talk about water, that was a great presentation about the importance of water to us that we just heard. And you're going to hear more before the afternoon is over. There's one thing that everybody should really embed in their minds when talking about water, though. First and foremost, it's more than just a curious, mysterious mix of hydrogen and oxygen. It's more than hydrogen and oxygen plus minerals. The really key thing to know about water is that it's alive, especially the ocean, because that's where not only most of the water is, it's where most of life on Earth actually lives. It's like a minestrone out there, but all the little bits are swimming around. It's really important to know this because we treat water, whether it's fresh water or ocean, as if it's just a commodity. And it's more than that. It's home for most of life on Earth. We need to show some respect for the circumstances that keep us and the rest of life on Earth here. No water, no life. No blue, no green. That's just the way it is. And what we've been doing to the waters of the world, fresh and salt, is just amazing. We have treated them with a great lack of respect, both in terms of what we're putting in, millions of tons of noxious substances, and what we're taking out, millions and tons of life. The attitude, both about fresh water and about the sea, until fairly recently has been that they're infinite commodities, that we can do with them as we would, without any real understanding of the consequences. But now we know there are consequences to what we've been doing to the natural systems that keep us alive. Most of this understanding has come in fairly recent times, mostly the 20th century, mostly the latter part of the 20th century, until about the middle point, about the time that my parents moved from New Jersey to Florida. We lived up in Dunedin, Clearwater, not far from here. We moved to Clearwater when Clearwater had clear water. Things have changed a little bit in the decades that I've been around coming here to this beautiful part of the world. We have learned in that time how vital the natural world is. About the ocean, we've discovered the existence of mountain chains. We've discovered that there's life in the ocean from the surface to the greatest depths. Actually, exactly 50 years ago, two men in a little submersible went to the deepest part of the ocean, 7 miles down. The only time people who've ever been to the deepest part of the ocean, go figure. But they found life all the way down, and at the bottom feel that they saw eyes looking back at them, a flounder-like fish, they said. And they knew it had to be something flat, given 16,000 pounds of pressure on every square inch. Joke, of course. But in the same time that we've been learning that continents move around, learning about the currents in the sea, learning about the scope and nature of life on the planet as a whole, we have seen more loss at the same time that we have gained more knowledge. About half the coral reefs in the world have been decimated, either gone or in a state of serious decline in just half a century. About 90% of many of the fish that we most like to eat have been eaten. They're gone. Tunas, swordfish, sharks, groupers, snappers, cod. What do you really love to eat? Think twice before you taking a bite out of some of the ocean wildlife until you really know what the real cost is. Hundreds of dead zones have been formed, even along the state of Florida, but around the Gulf of Mexico, coastal waters of the world are in trouble. And with climate change, the addition of carbon dioxide, the warming trend, sea level rise, also this growing concern about acidification of the oceans, and other changes in the chemistry of our life support system, mostly blue. So, what is the biggest discovery I get asked that sometimes. What have we learned about the ocean? I think the biggest, most important discovery is there are limits to what we can put in. There are limits to what we can take out. But now we know. We know that it matters what happens to the ocean because that's where about 70% of the oxygen is generated. It's the part of the planet that drives not just the water cycle, that should be obvious given that 97% of the planet's water is there, drives the carbon cycle. Think of fish as carbon-based units. Many of them are old, like tunas can be 30 years old, orange roughy can be 200 years old. They're the old growth of the sea that we are clear-cutting in the same kind of way that we have clear-cut forests on the land. The ocean governs climate and weather. It regulates temperature. Now we know that the ocean is the cornerstone of our life support system, so we should do everything that we can to take care of the blue heart of the planet that takes care of us. All right, so we've learned a lot about the ocean. What don't we know? When you think about it, as terrestrial creatures, our attention has been directed mostly to terrestrial places. We've learned a great deal, much still to be discovered about who lives even around the bark in a tree, let alone in forests on the land. But about 5% is all of the ocean that we have seen with the same kind of detail that we have accorded to terrestrial places. We only have about 5% of the ocean mapped with the same kind of detail that we have for the moon, for Mars, for Jupiter. We don't know this part of the solar system in a way that you'd think we would want to know, given that this is our home, that it is in trouble. The natural systems that keep us alive are in trouble. Therefore, what do you care about? The economy, your health, security, living? Then you should care about what we're doing to the natural systems that keep us here. So I want to take you to where I love to go. Splash, there we are. This is a place where, going back to the 1930s, two intrepid explorers, Otis Barton and William Beebe, went out in a place that previously had been known by the creatures who live there, the whales, the pteropods, the creatures that occupy that other space, that ocean space. They were the first to look out of a tiny little porthole in a metal sphere that was lowered over the side half a mile beneath the surface. Half a mile on the surface is no distance at all, but going deep in the ocean, it's still a pretty big deal. There are very few submersibles in existence today that can go to as much as 2.5 miles beneath the surface. The workhorse in this category is the Alvin that's been operating since the late 1960s, gone through many evolutions of change to make it easier and better for scientists and others to explore the ocean, to see creatures such as this in their own realm, jellies, comb jellies, creatures that, Jim Cameron in Avatar borrowed some ideas from his experiences in the sea. Bioluminescence, we know about fireflies and glowworms, sing songs about them, but the ocean is filled with living light. Something on the order of 90% of the creatures in the deep sea have some form of bioluminescence, the ability to flash, sparkle, and glow. And diving there, it's like falling into a galaxy of life and light. And I do hope that there will be rent-a-submarines out there in the not-too-distant future so anybody in this room can go to the nearest place and drive off into the deep and get a glimpse of what's really out there, to really explore the blue part of this planet, to see how filled with life it actually is. It is not just a place filled with rocks and water. It's a living system, and it's life that gives us oxygen. It's life that grabs the carbon. Where I shall be going very shortly, there is a forest that's even wetter than a rainforest. It's this floating golden forest of sargassum weed that Christopher Columbus described when he came to North America for the first time. It's in a rather quiet zone in the Atlantic Ocean where these masses of golden sargassum weed have given rise to unique forms of life that live there and only there. And they also are a haven for turtles that travel over the great pathways in the ocean. There they grow and get to a point where they can continue onward in their journeys that may be thousands of miles in the course of the time it takes for them to go from a little turtle hatchling to an adult that can lay eggs, a process that may take 15 or 20 years. You know, we don't raise 20-year-old chickens. We raise year-old chickens or less and derive food from the eggs that they produce and the rather good energy conversion of sunlight to protein to us. But what we take from the sea, turtles, tunas, swordfish, lobsters, the conversion of sunlight's energy through the small creatures that are mostly the source of the food that feeds the somewhat larger creatures that eat the tiny little planktonic plants on to the next generation. We're looking at a huge footprint when you have a tuna fish sandwich, thousands of pounds of plants into every pound of tuna that you munch on. Very quickly, I want to take you to one other part of the planet. Could we go to the Arctic? It is an example of a place now where we have a chance to get it right, to protect a part of the planet, like many other places in the sea that are in trouble, under threat from what we're putting into the atmosphere, to the ocean, what we're taking out as well. The next little video clip will be narrated, so I will listen right along with you. Could we have that next one, please? Gleaming starkly white, the frozen Arctic Ocean crowns the top of the world, above 66 degrees north latitude. In the Arctic, above the ice and below, wildlife prospers in what might seem to be an inhospitable environment. But it's exactly what is required for polar bears, ring seals, and the snowy white beluga whales, the highly vocal canaries of the sea. Narwhals, the legendary unicorns of the sea, and bowheads, the great ice whales, thrive there and nowhere else on Earth. In the cold, dark waters of the Arctic, life abounds, as it has for millions of years, unknown, unseen, and still largely unexplored. Under the ice, and actually within the ice itself, life is surprisingly rich and diverse. Photosynthesizing organisms cast a green glow across the sweep of the ice. Arctic birds, fulmars, guillemots, kittiwakes, and ivory gulls survive on a diet rich in Arctic cod, while murres dive down as deep as 100 meters in search of fish and squid. Walruses look elsewhere for meals, using their great tusks to plow into the soft underwater terrain to extract clams, worms, and other tasty morsels. And deep within the heart of the Arctic, 4,200 meters down, is the North Pole. Visited for the first time in August 2007 by 6 explorers in a pair of Russian submarines, Mir 1 and Mir 2. For hours, they observed and documented the seafloor, struggling to understand the nature of polar life far below the surface. The struggle to reach the North Pole at the Arctic's surface has lured hardy explorers for centuries.
Let's go! Wait!
Robert Peary and Matthew Henson claimed the first successful expedition in 1909. Other explorers to the Arctic Ocean have sought the fabled Northwest Passage, a direct shipping route from Europe to Asia across the polar ice. Today, global warming is melting the ice cap so fast that scientists expect the passage to become a reliable summer shipping route within a few decades. That's good news for shipping, but bad news for polar bears, Arctic seals, and the people of the Arctic, whose cultural heritage is inextricably linked to living in a realm dominated by ice and snow. Keen interest is now focused on the Arctic and its nature, particularly because of the magnified importance of the frozen northern waters in shaping global climate and weather, the circulation of ocean currents, and ultimately, the well-being of humankind. Biologist Ed Wilson is concerned that we may be letting nature slip through our fingers, but the greater concern has to be that nature may be letting us slip through her fingers. We have a chance right now on our watch. As never before we know what to do, as never again we have a chance to get it right. About 12% of the natural systems that keep us alive are protected on the land. A fraction of 1% of the ocean is similarly protected. Now's the time. Thank you.